Good day everyone. I am Muhammad Rizik A. Batuan and I will discuss about shadow price, the summary of the chapter 3, and example problem solution. Shadow price. What is shadow price? Shadow price is the maximum dollar amount the company would be willing to pay for one additional unit of a resource. It is the maximum amount the company would pay to get more of the resource. These dual values or shadow price are helpful to the company in making decisions about acquiring additional resources. You can see within the chart are the adjustable cells, constraints, and Excel spreadsheets. The shadow price or marginal value for labor is $16 per hour, and the shadow price for clay is $6 per pound. This means that for every additional hour of labor that can be obtained, profit will increase by $16. If the manager of the pottery company can secure more labor at $16 per hour, how much more can be obtained before the optimal solution mix will change and the current shadow price is no longer valid? The answer is at the upper limit of sensitivity range for the labor constraint value. A maximum of 80 hours of labor can be used before the optimal solution mix changes. Thus, the manager can secure 40 more hours, the allowable increase shown in the Excel sensitivity output for the labor constraint. If 40 extra hours of labor can be obtained, what is the total value? The answer is $16 hour times 40 hours equals to $640. In other words, profit is increased by $640 if 40 extra hours of labor can be obtained. Where increasing the labor constraint from 40 to 80 hours has increased profit from $1,360 to $2,000 or by $640. Summary. The summary of the chapter 3. This chapter has focused primarily on the computer solution of linear programming problems. This required us first to show how a linear programming model is put into a standard form. With the addition of slack variables or the subtraction of surplus variables, computer solution also enabled us to consider the topic of sensitivity analysis, the analysis of the effect of model parameter changes on the solution of a linear programming model. Example problem solution. Problem statement. The Setco Tool company is considering bidding on a job for 2 airplane wing parts. Each wing part must be processed through 3 manufacturing stages: stamping, drilling, and finishing, for which the company has limited available hours. The linear programming model to determine of part 1 or X sub 1 and part 2 or X sub 2 the company should produce in order to maximize its profit is as follows. Maximize Z equals to $650 X sub 1 plus $910 X sub 2 subject to 4 X sub 1 plus 7.5 X sub 2 less than or equal 105 or stamping hour. Second, 6.2 X sub 1 plus 4.9 X sub 2 less than equal 90 or drilling hour. Last, 9.1 X sub 1 plus 4.1 X sub 2 less than equal 110 or finishing hour. X sub 1, X sub 2 greater than equal 0. Objectives: A. Solve the model graphically. B. Indicate how much slack resource is available at the optimal solution point. C. Determine the sensitivity ranges for the profit for wing part 1 and the stamping hours available. D. Solve this model by using Excel. To determine the constraint lines, we should first to solve the drilling, finishing, and stamping. Drilling: 6.2 X sub 1 plus 4.9 X sub 2 less than equal 90. 6.2 times 0 plus 4.9 X sub 2 equals 90. X sub 2 equals to 18.37. 6.2 X sub 1 plus 4.9 X sub 2 less than equal 90. 6.2 X sub 1 plus 4.9 times 0 equals 90. X sub 1 equals to 14.52. Finishing: 9.1 X sub 1 plus 4.1 x sub 2 less than equal 110. 9.1 times 0 plus 4.1 x sub 2 equals 110. X sub 2 equals to 26.83. 9.1 x sub 1 plus 4.1 x sub 2 less than equal 110. 9.1 x sub 1 plus 4.1 times 0 equals 110. X sub 1 equals to 12.09. Stamping. 4x sub 1 plus 7.5 x sub 2 less than equal 105. 4 times 0 plus 7.5 x sub 2 equals to 105. X sub 2 equals to 14. 4x sub 1 plus 7.5 x sub 2 less than equal 105. 4x sub 1 plus 7.5 times 0 equals 105. X sub 1 equals to 26.5.
Solve the model graphically. This is the solution for objective A, which is point A is x sub 1 equals to 0, x sub 2 equals to 14, and the Z is equals to $12,740. The point B, which is the optimal point, is x sub 1 equals to 5.97, x sub 2 equals to 10.82, and Z equals to 13,722.49. In the point C, x sub 1 equals to 8.87, x sub 2 equals to 7.5, Z equals to $12,269.62. Point D, x sub 1 equals to 12.9, x sub 2 equals to 0, Z equals to $7,857.14.
Indicate how much slack resource is available at the optimal solution point. The slack at point B, where x sub 1 equals 5.97 and x sub 2 equals 10.82, is computed as follows. 4 times 5.97 plus 7.5 times 10.82 plus S sub 1 equals to 105, or stamping hour. S1 equals to 0 hour. 6.2 times 5.97 plus 4.9 times 10.82 plus S sub 2 equals to 90, or drilling hour. S2 equals 0 hour. 9.1 times 5.97 plus 4.1 times 10.82 plus S sub 3 equals to 110, or finishing hour. S sub 3 equals to 11.35 hour.
Determine the sensitivity ranges for the profit for wing part 1 and the stamping hours available.
Drilling.
The sensitivity range for the profit for part 1 is determined by observing the graph of the model and computing how much the slope of the objective function must increase to make the optimal point move from B to C. This is upper limit of the range is determined by computing the value of C1 that will make the slope of the objective function equal with the slope of the constraint line for drilling. 6.2 x sub 1 plus 4.9 x sub 2 equals to 90. Negative C1 divided by 910 equals negative 6.2 divided by 4.9 equals C1 equal to 1151.43. The lower limit is determined by computing the value of C1 that will equate the slope of the objective function with the slope of the constraint line or stamping. 4x sub 1 plus 7.5 x sub 2 equals 105. Negative C1 divided by 910 equals negative 4 divided by 7.5. C1 equals 485.33. Summarizing, 485.33 less than equal C1 less than equal 1151.43. The upper limit of the range for stamping hours is determined by first computing the value for Q1 that will move the solution point from B to where the drilling constraint intersects with the x sub 2 axis, where x sub 1 equals to 0 and x sub 2 equals to 18.37. 4 times 0 plus 7.5 times 18.37 equals Q1. Q1 equals to 137.76. The lower limit of the sensitivity range occurs where the optimal point B moves to C, where x sub 1 equals 8.87 and x sub 2 equals 7.15. 4 times 8.87 plus 7.5 times 7.15 equals Q1. Q1 equals to 89.10. Summarizing, 89.10 less than equal to Q1 less than equal 137.76.
Solve this model by using Excel. In the screen, you can see the solution to the problem with all the production costs given as solved using Excel. And that's all. Thank you for listening.